I've pushed this all semester, even last semester. I've pushed for you all to not get so caught up in memorizing steps and just seeing a problem and be like, oh yeah, I gotta do this step, and that step, but actually understanding and putting language around everything that we're doing. We need to continue to do that. Okay. Basically, this lesson, this dividing lesson, we're gonna for here this week into next week, we're gonna continue to divide. So it's gonna show up time and time again. And there's two methods that we're gonna look at. But we're gonna actually start out with long division, just like what we do with numbers. Okay, so again, the exact same procedure we did up on the board with our numbers, we're gonna do here with polynomials. So let's start off with, what do we accomplish by doing the division? Well, we actually have been dividing polynomials every time we've been factoring. Okay, so we've been doing this. We haven't done it in the exact same procedure, but when you've taken a quadratic and you've given it to me in its factored form, you've done a form of dividing. Okay, yes, it's not the same procedure, but it accomplishes the same thing. And so where we're at, not every polynomial can be factored the way we've already discussed. Not every polynomial can factor by grouping. Not every polynomial is a sum of cubes or a difference of cubes. So we need other tools to find solutions to polynomials that aren't factorable. That's where division comes into play. Division allows us to essentially factor every single thing that could potentially be factored. Okay, so this is like kind of like the quadratic formula. When everything else fails, you can go and use the quad formula and get your solutions. This is kind of like what division is with factoring. When we can't factor with any method that we know, division is kind of our last resort. Okay, or at least for what we're going to use it for in this class. It does have other uses in other units as well. So the main point here is division is factoring. And as we factor, that's going to help us find solutions to higher degree polynomials, right? Like if I have something x to the fourth, we don't have a way to factor that. And so our way of how we would find solutions is going to resort back to the division piece. So in dividing polynomials, we're going to decide if the given divisor referring to what we're dividing by, is a factor of the polynomial that we are given. Okay? So it's a lot that we're going to be able to decide. Well, not a lot, but we'll be able to say, hey, x plus 1 is a factor, or we won't be able to. And if it's not, it's almost a waste of time. Okay? And that ends up happening quite a bit with the division here. But we're going to focus more so on the procedure. But the main kind of thing I want us to remember why we're doing this is it's a way for us to obtain solutions because we're really just factoring. All right? So here's how the procedure goes. Again, just like with numbers. So we're going to set up our division bar. We're going to put what we're dividing by on the outside there. Underneath the division bar is what we're dividing. So x to the fourth minus 4x cubed minus 12x squared minus 6x plus 1. Okay, and our task, just like with the numbers, is to figure out how many times can we get x plus 1 to go into either the first term or maybe the first two terms. It all depends on how many terms we have for what we're dividing by. So we're dividing by two terms. So really what we're trying to do is figure out how many times does x plus 1 go into x to the fourth. Okay, I guess that is kind of one difference here, that we're trying to figure out this first term, how many times can it go into x to the fourth? And we're going to subtract those away. So really what we're thinking about here is x times what is x to the fourth? And that would be x cubed. And so what I'm going to do with the number that I chose here, and again, I chose this x cubed because x cubed times this x gives me x to the fourth. And we're going to multiply the x cubed by this whole term for what we're dividing by. So x cubed times x gives me that x to the fourth. That was our first priority. Okay, was to get that x to the fourth, and so it'll subtract away. But that x cubed also needs to multiply to this positive 1 right here. So x cubed times positive 1 gives me a positive x cubed. And now our task is to subtract away what we're dividing by these two terms we just came up with. So I will say, I'll write down my subtraction. I'll also put parentheses around the terms that I'm subtracting, because this is where most mistakes happen. We're so used to adding this way because, right, it's kind of like when we're doing systems of equations and we just add. So what happens here, a lot of students, they go, okay, x to the fourth minus x to the fourth, those cancel. That's what we're always trying to accomplish. But then so many students will get here and they'll say, oh, -4 plus 1 is -3. But they forget that we're actually subtracting. So that's, again, going to be the most common place to make mistakes. So the parentheses, they just serve as a reminder that I am subtracting. And so the signs that I see here with these terms are not the signs I'm going to use when combining my terms. So really, this is a -4x cubed minus 1x cubed, which makes this -5x cubed. Okay, so the subtraction piece, be very thoughtful about what or how that's going to go. That is the most common place to make mistakes. So after we've done the subtraction, I'll bring down the next term, -12x squared, and we start all over. So that's what's nice about this, is it's really just a couple steps, and then it just continues to repeat. So now, back to the initial step, we want to figure out how can we get rid of this -5x cubed. And we do that by thinking about x times what gives me that -5x cubed. That would be a -5x squared. So -5x squared times this x makes this -5x cubed. But that -5x squared also gets multiplied to this +1. So -5x squared. And now once again, I'm going to subtract away those terms. -5x cubed minus a -5x cubed, we're really adding the second 5x cubed, so those cancel out. That's always kind of our main goal, is to eliminate that first term. And then, again, this is where a lot of students will be like, oh, -12 minus 5, that's -17. But it's really -12 minus -5, so we're really adding the 5, making this -7x squared. So I'm going to bring down the next term and start all over. So now I'm focused on getting a -7x squared, thinking about x times what gives me that -7x squared. That would be -7x. So -7x times 1x is this -7x squared. And that -7x also needs to multiply to the +1, so -7x. And once again, we're subtracting. So -7x squared minus the -7x squared, those cancel. And then I have -6x minus -7x. We're really adding 7x, making this a +x and +1. And so now I'm thinking about x times what is x? That would be a +1. So I'm going to take this 1, multiply it by x and by 1, and subtract away these terms. I'm running out of room here. So I have x minus x, those cancel, and 1 minus 1 also cancels, giving us a 0. Okay, and we have nothing left to divide. As soon as we get, after the subtraction, a term that is a smaller degree than what we're dividing by, we're done. And this remainder of 0 is really important. When we get a remainder of 0, that means that this term divides into the polynomial perfectly. Okay, just like if we are dividing numbers, if we get a remainder of 0, that means the number we divided by goes in to that entire number or the divisor goes into the number we are dividing by. And so what this tells us is that x plus 1 is a factor of x to the fourth minus 4x cubed minus 12x squared minus 6x plus 1. Okay. And so really what we can do, this polynomial, because we factored, what we can say that this is equal to now is that x plus 1, which we have confirmed is a factor by getting that remainder of 0. So if we take that x plus 1, our divisor, and multiply it by the quotient, the result of the division problem, that equals our original polynomial. Okay, so now, if we wanted to continue to find solutions, we've got to work with this cubed function, so x cubed minus 5x squared minus 7x plus 1. And we have tools to maybe factor that, but if we can't factor by grouping there, we would continue to do long division with anything we think might be a divisor. We're not going to do that because that actually, we have a process for that we're going to work on next week. So what I want us to focus on today is more just the procedure. Okay, understanding that when the remainder is 0, it's a factor. We will focus on the factoring piece in a later lesson. Okay, so as a reminder, if there is a remainder after dividing, the given polynomial is not a factor. And it really accomplishes nothing. Okay, if we get a remainder other than 0, we don't really do much with it. Okay, there is a way that we'll state it, but it doesn't help us in terms of what we use this for. But if there's no remainder after dividing, then the given polynomial is a factor. So we're hoping that we get, especially when we start putting this to use, remainders of 0. Okay, so let's do this. I'm going to just set up number 2. I'll run through the first step, and I'm going to have you all take it from there. And that'll be as far as we get today. Okay, we'll just do one more problem with this, and we'll pick up right with this after on Friday. Okay, so like I mentioned, if we know that a given divisor is a factor, we can use that to start to find solution to the polynomial. So just backing up real quickly, because x plus 1 is a factor, that means that -1 would be a solution, right? Because after factoring, I would set x plus 1 equals 0, and I get -1 as an answer. Okay, again, that's something that'll come later. Just want to have those things on our radar at this point. Okay, so I have x minus 5 as my divisor, and we are dividing 6x to the 4th minus 24x cubed minus 25x squared minus 30x plus 32. And I'm going to do the first step, and then you all take it from there. So again, our first task is to eliminate the first term here. So we want to get another 6x to the 4th by thinking about what can we multiply this x by to get the 6x to the 4th. Well, for sure 6, and then we need an x cubed times that x to get the x to the 4th. So 6x cubed times x gives me that 6x to the power of 4. And then 6x cubed times -5 is -30x cubed. And we are subtracting those terms. So 6x to the 4th minus 6x to the 4th cancels. And then I get -24x cubed minus a -30x cubed. So I'm really adding the 30. So -24 plus 30 gets me a positive 6x cubed. Bring down the next term and start all over. And that's where I'm going to have you all take it from here. And you should have to do this 1, 2, 3 more times. Okay, so go ahead and work through this the best that you can. Again, give it a try. Don't just sit there and do nothing. I will have it all worked out. We'll check that, and we'll call it a day after that. Won't be no extra homework on top of this. So here is all the work leading up to this, and here we should find that we do get a remainder, okay, and your remainder of 7. So if you did not get a remainder of 7, you did make a mistake somewhere along the way. Again, more than likely that mistake happened when you were subtracting. Usually I don't see a lot of mistakes with the multiplication. It is more with that subtraction there. Okay, so I am going to encourage you to go back. These are one of the harder problems for me to check. Like when you make mistakes and you say, hey, Mr. Younger, can you come check my work? It's not an easy or it's not a quick thing for me to check. I can do it, but it takes me a little bit to do that because I've got to check all your signs and all the addition and subtraction. And so this is one thing that going slow and being very cautious is really helpful for not getting things incorrect. Okay. Now, we've got plenty of time, so hold your stuff for like 1 minute. Okay, I'm almost done here. The remainder. Again, when we get a remainder, that basically that means that it's not a factor. So x minus 5 is not a factor, and it doesn't accomplish much for us. The last thing I want us to mention is how we can add in the remainder to this equation so that we're still getting some kind of division done. So this is the way, kind of like the version, how we would describe a decimal with polynomials. Okay, if we were dividing numbers and it didn't go in perfectly, we would get a bunch of decimals, right? Well, how that happens with polynomials, we take our remainders, the remainder of 7, and we add it on to the quotient, so the result of our division, and we just say that that 7 is still going to get divided by x minus 5. So the remainder, how we add it into the quotient, is you say plus the remainder, and that remainder divided by whatever term it is that we were originally dividing by. All right? Well, we will stop there, and we will pick up with this on Friday.